Hello all, today we are going to cover 5.2, factor and multiply polynomials. You guys will be able to analyze the factored form of a polynomial and write the polynomial function from its zeros. So, finding the zeros of a polynomial function will help you factor the polynomial, graph the function, and solve the related polynomial equation. This first problem, we are going to find the factored form. So first thing we should do is check for a greatest common factor. There is something we can pull out of each of these, that is an x, which means we take it to the outside of the parentheses and then divide each term by that. Write our new version with the x pulled out down below and in parentheses. And then we want to go ahead and factor out the squared quadratic part. This is back to what we did last chapter. You want to find factors of 15 that subtract to -2. So we have x minus 5 and x plus 3, because -5 times 3 is -15 and -5 plus 3 is -2. And bring down that x that we pulled out for the greatest common factor. And we have our factored form. We are good to go here. You'll notice step 2, they want us to find the zeros. So we go ahead and we just set each part equal to 0. So we know, because of this cubed here, that there should be 3 solutions. We will have x equals 0, we will have x minus 5 equals 0, and we will have x plus 3 equals 0. And then go ahead and solve for x. So x equals 5. And x equals -3, and we also have the x equals 0, and those are our solutions. Now, if you notice for this next step, when we have a solution to our polynomial, that is just the opposite sign of what we had in our factorization. So if we want to go backwards from the solutions, or the zeros, back to our original form like this, we want to go ahead and just take these and put them in parentheses with the opposite sign. So it'll look like that. That is the factored form from the zeros. Then, to get it back to standard form, that's when we have like x cubed plus x squared plus x plus a number. That's our standard form. We need to FOIL, although we can FOIL on the first one, first, outer, inner, last. The next step, we will have to do a similar thing to FOILing, but we can't use the acronym. So we end up getting x squared minus 3x plus 2x minus 6 from this first FOIL. Then we need to multiply those terms. Well, first of all, got ahead of myself. We should combine like terms first. So we should combine these two to be like, because they are like terms, to be -1x minus 6. Now, we have to take that trinomial and multiply it by the remaining binomial down here. So I am going to go ahead. The reason we can't really say FOIL now is because we have more than 2 terms in the first group. So we instead are going to just know that we distribute each piece through. So the x squared goes through, the -x goes through to both, and the -6 goes to both. We don't want to leave anybody behind, so I'm going to do the x squareds first. So x squared times x is x cubed. Then we have -3x squared. Then we have -x squared. Then we have -x. Then we have -3x, positive 3x, oh man, positive 3x minus 6x plus 18. There we go. So I should have 6 terms here. We are good to go with that. Then I go ahead and combine like terms. There's a couple sets. We get x cubed minus 4x squared minus 3x plus 18, because I combine these guys and combine those guys. And that is our standard form, greatest degree to smallest degree. Now on these next ones, we're moving into something a little different. We still are going to factor though and find the solutions. If a solution shows up more than once, that is called a multiple zero. So in this case, 3 and 3 showed up more than once, that would be a multiple zero. Specifically, if a factor appears twice, you say it has multiplicity of 2. If it appeared 3 times, it would be multiplicity of 3. Negative 2 only shows up once, that's multiplicity of 1. So we are going to find the zeros of each function and then state the multiplicity. So for this guy, once again, look for greatest common factor. The greatest common factor is also x here, but it's 3x because we can also take out the number 3. Reduce or divide each term by that, so we are left with x squared minus 1. For that, we do know we need to solve, so equal it to 0, so we have 3x equals 0, and we have x squared minus 1 equals 0. Go ahead and solve for x. Remember, if you have a square root that you're doing to solve for x, you're going to end up getting 2 solutions, the positive and the negative version. And then our third solution here is just x equals 0. So because all of these are different numbers, each zero, or each solution, has multiplicity of 1 because they only show up once. Okay? This next one, because there is this 2 here, that does not mean distribute the 2 through. It means that that whole parenthesis shows up twice. So you can rewrite that. This is pretty nifty because it's already factored for us. We can just set each parenthesis set equal to 0. Maybe I should have used a different color, huh? Just go like that. And then solve for x. So x is going to equal 2. X will equal 2 again, and then x will equal 1. So we have 2 has multiplicity of 2. And 1 has multiplicity of 1. That has nothing to do with the number it is, it's just how many times it shows up as a solution. All right? Then we also know if the graph of a polynomial function has several turning points, the function can have a relative maximum or a relative minimum. A relative max is the value of the function at an up to down sad face. So if we had a graph that looked like this, oopsie. This point here would be a relative maximum, while a relative minimum is the value at the down to up or a happy face. Okay, so that is the relative. That is not saying it's the absolute max or the absolute min, because this continues more maximum and it continues more minimum. So it's just relative. These are important because when we're graphing something in a real world situation, a lot of times where it changes directions are the important points to look at. So I'm going to show you how to find the relative max and min using your calculator. All right, now that we have our calculator, we need to turn it on, and then we can go to the y equals button. When we are here, we need to plug in the equation of our polynomial. So I'm going to hit this special x button here. You'll notice it says x, t, something called theta, and then n. You'll hit that, and then to get the little exponent, you'll hit this caret button. You'll see it goes up to the exponent, and then you can type a3. And then this guy up here, he's kind of like a cursor. He tells you what to do next. So he tells you to arrow over, and then you're back down to your regular cursor. You can type 3 plus 3 that special x squared, arrow over again, minus 24x. Then you hit this graph button here. You'll notice the graph goes on there. If you want to either zoom in or out, you can hit the zoom button and then either hit in or out. If I hit in, I can hit in and then hit enter again. It goes back to the normal look. I do want it to be the further out version though, just so I can see where it changes directions. So I'm going to zoom back out here. Ooh. All right. So the goal is to find where it switches directions. You'll notice as it graphed it, we have a relative max up here. It's actually off the graph, but we can still figure out what that point is. And then our relative min is down here. So to do that, you are going to hit the second blue button and then hit the trace button. It actually says calc there. And you can either find min or max first. I'm going to find the max first and hit enter. Now down in the bottom left corner is kind of your directions. It's your GPS telling you what to do next. It wants the left bound for our maximum. So go to the left side, see the little star going there. You're going to move to the left side of the maximum point by just hitting the arrow over and then touch the enter button. The enter button will take you and put this little triangle up here saying, okay, this is our left bound. Now it's asking me, what's my right bound? So I arrow over till I see my star on the right bound. Now don't go past the next turning point. It'll get confused. Stay between them right here. You hit enter then for the right bound. And then it asks, you want me to guess? Say, yeah, enter. And it'll guess your maximum point. So that maximum point, you will actually put it in parentheses, and it'll be -4,80. Then we go ahead and we hit the second button and the trace button again and decide, okay, we need to do the minimum. So it wants the left bound again. This time we want the left bound of this turning point minimum. So we arrow over. It's got to be on the left side between the two turning points, hit enter. Then we want the right bound, so arrow over to the other side of the minimum, hit enter, and then say, yeah, I want to guess, hit enter again. And then it guesses that that minimum point is at 2, -28, and you have found your maximum and minimums using the calculator. That's all. Have a great day.